Today I am going to explain about periodic trends and chemical reactivity. Periodic trends and chemical reactivity. So what is periodic trends? What is chemical reactivity? So periodic trends means specific patterns present in the periodic table that explains the different aspects of element. Different aspects of element. Periodic trends explains the different aspects. That means different aspects means atomic radius, electronegativity, ionization energy, electron gain enthalpy, ionic radius, valency and oxidation states. All these are under periodic trends. That means periodic trends explains the different aspects of elements. Different aspects of elements. And whereas coming to the chemical reactivity. So chemical reactivity means reacting nature of element. Reacting nature of element. One element, how it is reacts with other elements. So that is reacting nature. So chemical reactivity means reacting nature of elements. Periodic trends means explains the different aspects of element. These periodic trends and chemical reactivity is related to, all these are related to electronic configuration of element. Electronic configuration of elements, right? So reacting nature or atomic radius, electronegativity, ionization, all these aspects of elements are purely depends upon electronic configuration of elements, right? So here I am taking period 3 elements. Period 3 elements. So period 3 elements are sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, right? So helium, neon, argon, krypton, xenon, radon. These are noble gases, right? So noble gases having zero reactivity. Reactivity nature of these elements is very less and zero reactivity. Why? Because noble gases are most stable. That's why it cannot react with other elements, other atoms. Helium, neon, argon, krypton, xenon, radon, all these are noble gases or reacting nature is zero. Why? Because noble gases are most stable. That's why it cannot react with other elements, other atoms. Okay? So, I am consider these elements only. So, reactivity nature at highest at 2 points. Whereas coming to lowest at center. Reactivity nature is lowest at center and highest at 2 points, that is left side and right side of a period. Okay? Reactivity nature is highest at 2 points, left side of a period and right side of a period. So here highest reactivity, here also highest reactivity, but at the center lowest reactivity. Why? Because here highest reactivity due to the ionization energy least, and metallic character is increases. Metallic character is increases here. Increases here and here. Here also highest reactivity nature due to metallic character is decreases, right? Metallic character is decreases, and the second one is high electron gain enthalpy. High electron gain enthalpy. So these are the reasons for high reactivity. Okay, these are the reasons for high reactivity. The chemical reactivity is highest at 2 points. That is left side of a period and right side of a period. And reactivity nature is lowest at center of a period. Okay, so here also highest reactivity, here also highest reactivity. Here also highest reactivity is due to the ionization enthalpy is least here. Why? Because least. Ionization enthalpy means what? The energy is required to remove this electron. Remove this electron from an isolated gaseous atom. The energy is required to remove this electron, remove this valence shell electron is called ionization enthalpy, ionization energy. So these elements have ionization enthalpy is least. Whereas coming to the second point, metallic character is increases. Alkali metals, alkali earth metals, right? These are the alkali metals, these are the alkali earth metals. Group 1 elements, group 2 elements are purely metals. Purely metals. So metallic character is increases. That's why reactivity nature also highest here. Reactivity nature also highest here. Ionization energy, ionization enthalpy is least here. Energy is required to remove this electron from it. Remove this electron from it. This energy is least here for these elements. These are the two reasons for high reactivity. These are the two reasons for high reactivity. Here, let us discuss about here. So, right side of period. Right side of period also, these elements also having highest reactivity. Due to metallic character is decreases. So, from in a period left to right, metallic character is decreases. Here elements having high metallic character. Here having very low. That means non-metallic character increases here. Right? These are the P block elements. These are the S block elements. Right? So, from the left to right, metallic character is decreases. That means these elements are non-metals. Right? So, that's why metallic character is decreases here. And the second one is electron gain enthalpy is high. What is electron gain enthalpy? Energy is released when an electron is added to it. Energy is released when an electron is added to that of atom. This is electron gain enthalpy. These elements having high electron gain enthalpy, that means negative electron gain enthalpy. These elements have it. It means energy is released when an electron is added. Electron gain. We have to remember that electron gain means adding. So energy is released when an electron is added to the atom. So these elements are having high electron gain enthalpy, that means negative value. So negative value. Noble gases have positive electron gain enthalpy. Why? Because these are more stable, right? These are more stable. So it is difficult to add the electron to it. It is very difficult to add the electron to it. So we need so much energy. That's why we need energy, not released. We need energy. That's why positive symbol. Here the energy is released. That's why negative symbol. Here energy is released. Here energy is observed. That's why positive symbol. Okay. So high reactivity is due to the metallic character is decreases here, and the second one is high electron gain enthalpy. That means so much of energy is released when an electron is added to these atoms. Electron is added to these atoms. That's why reactivity nature is highest at 2 points. Left side of a period and right side of a period, and lowest at center. Lowest at center. Reactivity nature is best shown by formation of oxides. Formation of oxides explains the reactivity nature clearly. So this is period 3 elements. So reactivity nature is highest at 2 points. Highest at 2 points. Here left side and right side of a period. Reactivity nature is very high at 2 points, and at the center low reactivity, right? So at the center low reactivity. So reactivity nature is best shown by formation of oxides. These elements are reacts with oxygen to form oxides. All these elements are reacts with oxygen to form oxides, right? So these oxides here, so oxides of these elements: sodium oxide, magnesium oxide, and oxides of these elements: Cl2, O7 and SO2, SO3. Oxides of these elements are basic in nature. Basic in nature. And oxides of these elements are acidic in nature. Acidic in nature. What is acidic? What is basic? The pH value is low, then substance is acidic in nature. The pH value is high, then the substance are basic in nature, right? For example, this is pH scale. Consider 0 to 14, right? 0 to 14. 0 to 7, the pH value is 0 to 7, then acidic in nature. Then the substance is acidic in nature. When 7 to 14, basic in nature. Where is 7? 7 is neutral, right? Neutral. 7 is neutral. Where is 7 is neutral. So 0 to 7, acidic character. 7 to 14, basic character. And 7 is neutral, right? We all know that. So oxides of these elements are basic in nature. Basic in nature. Reactivity nature. I am explaining reactivity nature. So reactivity nature is best shown by formation of oxides, right? So oxides of these elements are basic in nature. Oxides of these elements are acidic in nature. And at the center, oxides of these elements are amphoteric. Amphoteric in nature. That means shows both acidic and basic properties. Both acidic and basic also. So oxides of these elements, that means the center of the period, these elements or oxides are amphoteric in nature, and the left extreme and the right extreme of these elements oxides are basic and acidic in nature, reactivity in nature. Okay. So amphoteric Al2O3. So these are the amphoteric oxides. It means it shows acidic natures, basic natures also. Acidic nature, basic nature also. But oxides of these elements shows basic in nature. Oxides of these elements shows acidic in nature. But at the center the reactivity is low. That's why it forms amphoteric oxides. Amphoteric means shows both acidic and basic. Okay. Thank you.